Good morning, friends. Mrs. McBride here, coming to you live from my kitchen table. Today we are talking about two different topics. One is Ohm's law, which will be the focus of the beginning of the week, and the second one is electric power, which will be the focus of the middle of the week. Okay, so first, here you go. Why did the pig have to sit on the bench during football practice? He pulled his hamstring. The jokes just keep getting better. All right, the first thing we're talking about today is Ohm's law, and Ohm's law is the relationship between voltage, current, and resistance. The equation says V equals IR. Or if we were to write this in words, we would say that voltage equals current times resistance. And I'm going to put a whole bunch of stars around this because, as you know, in every topic there's that one equation that is really important. Guess what? This is that equation, okay? This is the one that is super important and that we're going to use all the time. V equals IR. Now, some people even want to go crazy and write this in different ways, right? So you could solve this for I. Right, so if V equals IR, then I would just equal V over R. And we could also say that R, again, if we solved for R, equals V over I. Okay, now on my green sheet, pause if you don't have your green sheet going. I just want to go ahead and add this to my green sheet. V equals IR. Now I am sort of running out of room here because I also want to add that V is voltage. Hopefully you guys wrote smaller than I did. And R is resistance. Okay? All right, so if we take a look at this problem here, this problem says, a typical color TV draws 2.5 amps of current when connected across a potential difference of 115 volts. What is the resistance of the TV? Okay, so what are we looking for here? Well, we're looking for the resistance. So in this case, R is our question mark. Now what else do we have here? Well, we also have 2.5 amps of current, and remember that current is given by the symbol I. So we've got that I is equal to 2.5 amps. And last but not least, we've got V, or our voltage, right? So remember, potential difference is just a fancy name for voltage. We've got that our voltage is 115 volts. Now, since I'm solving for R, I'm going to use this version of the equation and say that R is equal to V over I, or that it's 115 divided by 2.5. Please take a second to solve. What you should have gotten is 115 divided by 2.5, or you should have found that the resistance is 46 ohms. Okay? We're not going to worry about ohmic versus not ohmic. That was going to be important for the lab that we were doing in class, but since we're not in class, we're going to skip that. Okay? So again, this is really important, and we're going to practice this later in the week. Okay? Using V equals IR. The second part I want to talk about today is something called electrical power. Okay? Electrical power is the rate at which charges do work. The rate at which charges do work. Now, if you remember from regular power, when we talked about like we were running up the stairs and we said, ooh, what's our power? Okay, what was the symbol for power? Hopefully you said to yourself, capital P. And watt are the units. The jokes don't get any better. The units are watts, or W. And remember, this is the rate at which things do work. So if you think about a light bulb has a power of 100 watts, okay? That means that it's the rate at which the charges do work. So basically the charges do 100 joules of work every 1 second. Or let's say it's a 60 watt light bulb. That means they do 60 joules of work every 1 second. A 60 watt light bulb is not as bright. Okay, well, the reason why it's not as bright is the charges are not doing as much work as a 100 watt light bulb. Life lesson, the more work you do, the brighter you are. Just kidding. Okay, so we can use the following equation, and I say equations because there's a bunch of different ways that we could write this one. So again, have your green sheet ready. We're gonna put this on there. Now, in general, power is equal to current times voltage. I like to remember this like IVs give you power. You'll probably hear me say that a couple different times. IVs give you power, okay? But we can also write this in a couple of different ways. All right, so come down here for a second, okay? Well, what if we don't have the current or the voltage? Well, what if we say power is equal to current times voltage, and we know that voltage equals current times resistance, we should be able to plug that in there and get that power is equal to I times IR, or we could also say that power is equal to I squared R. Now, why would you use this? Well, it depends on what variables you have, which power equation you want to use. Yes, don't worry, we can do this again. Here you go. Going down here. And again, you don't have to write this down. This is just, I don't want to just give you all these equations and you thinking to yourself, where did these come from? These are just in case you want to know, well, where does this come from? We also know that I is equal to V over R. If we take this and substitute that in there, you get V over R times V, or V squared over R. And again, you'll never be asked to derive these. This is just my fun fact for the day. All right, so all of these equations are equal to power, and depending on what we have, so we're gonna practice here, we'll figure out which one we need to write. All right, so back to your green sheet. Again, pause this video if you need to go back to your green sheet. Power is equal to IV is equal to I squared R is equal to V squared over R. And again, it depends on what we have. And I'm going to add down here that P is equal to power measured in watts. All right, let's practice. This question says, how much current flows through a 100 watt light bulb connected to a 120 volt DC power supply? So what do we have here? Well, 100 watts, this is your power. 120 volts, hopefully you're saying to yourself, hey, that is our voltage. And last but not least, what are we looking for? Well, we're looking for our current. So we're looking for I. Okay, well, based on what we have, which equation should we use? Equation number 1, equation number 2, or equation number 3? Hopefully you all picked 1, which says P equals IV, or we're going to take our power, which is 100 watts, equals I times our voltage of 120 volts. If we grab our calculator here, we can take 100 watts divided by 120 volts, and we should see that in this case our current is 0.833333. And then what are the units of current? You're right, amps. All right, now the second part of this question, this one says, what is the resistance of the bulb? Well, it turns out, if we go back to our equations here, we could do this a couple of different ways. We have P equals I squared R. We also have P equals V squared over R. Or, look at this equation up here, our favorite one. V equals IR. You could really do it any of the three ways, but I would do it using V equals IR because that one's the easiest. So we have our voltage up here, which was 120. We have our current, which was 0.833, and you're looking for your resistance. So you should be good to go to take our voltage and divide by our current to find that our resistance is 144.06. What are the units again of resistance? Yep, ohms. All right, friends, have a nice day.